G'day everyone. Today we're going to be talking about the difference between a point temperature and a delta temperature and how we go about to convert these types of temperatures in the different scenarios. So the first thing we're going to look at is the point temperature. And this is a temperature that you are all familiar with. It is a single standalone measurable temperature and is always indicated by some type of variable in an equation. So how would we go about to convert, let's say, this density equation so that we can use the temperature as degrees Fahrenheit instead of Kelvin? Point temperatures are always converted using some type of formula that gives you the correlation between the two temperatures you want to convert to. As you can see, this equation looks a lot like a straight line. We can explain the reasoning for this by looking at the 4 different temperature scales. If we plot a line for different degrees Celsius values and we plot the corresponding lines for the 3 other different temperatures, we can see that each of the lines crosses the y-axis at different points. And this is because each temperature scale has its own 0 point, and this fact will be taken into account by the C value in our equation. We also see that the gradients for each of these lines are different, and this is why we have a gradient value in our conversion equation. So how do we go about to derive or set up this type of equation for our conversion? So let's go back to our density equation. We want to convert the temperature variable from Kelvin to degrees Fahrenheit. So first of all, we need to derive an equation that describes the relationship between Kelvin and degrees Fahrenheit. So we can start with the most known formula where degrees Celsius is converted to degrees Fahrenheit and vice versa. And we also have the equation that describes degrees Celsius in terms of Kelvin. So if we can combine these two formulas, we can get a formula that describes degrees Fahrenheit in terms of Kelvin. But how do we derive the equation that describes degrees Fahrenheit and degrees Celsius? Let's go look at the scale where we have 2 degrees Celsius values and 2 degrees Fahrenheit values. We use this formula, which is delta temperature 1 over delta temperature 2, to describe the relationship between the two equations using our scale. And if we rewrite or rearrange this equation, we can see that it gets back to the general straight line equation. Now, if we sub in the variables or the 0 points for our 2 temperature scales, you can see that we can derive the original equation that describes degrees Celsius and degrees Fahrenheit in relationship with one another. And this principle or this equation can be used to describe or derive an equation that describes 2 temperatures in terms of one another for any type of temperature scale, as long as you have 2 corresponding temperatures for each of your scales. So now that we know how to derive this equation, and we can rearrange our degrees Celsius and Kelvin equation, sub it into one another, and now we have an equation that describes degrees Fahrenheit and Kelvin in one. We can use this equation, plop it into the density equation, and if we finally rearrange it, we'll have a final equation where we can use degrees Fahrenheit directly to calculate the density of some substance. So next up, we're going to have a look at the conversion of delta temperatures. A delta temperature is literally what it sounds like. It is the difference between 2 point temperatures, as seen in this equation, and it will always be indicated as such in any type of equation. So let's have a look at this. We have temperature A and temperature B in both degrees Celsius and degrees Fahrenheit. So we calculate the delta temperature for both of the 2 scales. If we wanted to convert the delta temperature directly without having to convert the individual point temperatures, how would we go about this? Well, most people would be tempted to do something like this, where we use the point temperature equation to convert the delta temperature. we can see that the converted delta temperature and the calculated delta temperature for degrees Fahrenheit is not the same. And the reason for this is a delta temperature is the change into point temperatures. So it stands to reason that if we wanted to convert the delta temperature from degrees Celsius to degrees Fahrenheit, we would need to convert the individual to point temperatures. So if we sub in the point temperature equation and we work out what the end result is, we can see that at the end, we only need to use the gradient to convert between delta temperatures. And this can be applied for any type of temperature scale conversion as long as we can calculate the delta ratio between the two temperature scales. So to recap, a point temperature is a standalone measurable temperature and is always represented by a standalone variable in an equation. A delta temperature is the change into point temperatures and will always be indicated as such in an equation. Point temperatures are always converted using an equation that describes the relationship between the two temperatures. Delta temperatures are always converted using only the gradient change between the two temperature scales. Delta temperature scale conversion is also always applied in unit conversion. Any temperature variable in units is always considered to be a delta temperature. Therefore, we only use the delta temperature method of conversion where we use our gradient to convert between the two temperatures. And that's it, guys. I hope you enjoyed today's lecture. Please leave a like and a comment down below for any future lecture requests that you have. Have a nice day.